Good morning. My name is Efo Salawani. Here with me, I have a project that I've designed, and this project is what I've been doing for years now. So I've used it to help my clients to convert their machines whenever there's a major breakdown, because most of these machines are being bought in overseas. So once they install them here, install the machine for them, sometimes to sort out the parts is always difficult. They have to wait, and the time of waiting production is already no production is going on, and the client wants the machine to be fixed. So as an engineer, I came up with this project to ensure that this project solve the problem of my clients. So I have to first of all check how the machine works, know the principle of operation. Then I came up with this design, then use it to solve the problem. I've been doing it for years now for my clients back then in Nigeria. So the name of this project is called PET Blowing model the machine. So it's a control panel that controls the molding section of the machine. So a PET blowing molding machine, what it does is that it has a preform is heated. Once the preform is being heated, then the operator takes the preform, or the machine, if it's a fully automated machine, then the heated preform is taken to the mold. Then on a high pressure air is being injected into the preform and expand the preform to the shape of the mold. So that is why today you see various bottles, you see different shape, different design. It is the mold design that form that shape. So that is why you see those design in those bottles. So now, PET blowing machine has 4 segments, which I'm going to explain those 4 segments briefly. We got the chiller section. What this chiller does is to cool the bottle, the preform, once the preform is being formed. So because once the preform is not formed, once the preform is not cooled or chilled after being formed, you can see the deformation on it. Maybe the head of the cap will be a kind of a bit larger, which is already causing waste. So for us to prevent such incidents, so chiller is installed on those machine. Then we got the heater, the heating section. The heating section, what it does, that is where the preform is being the operator put the preform on the heater. The heater heats the preform. Then the preform will now be taken and put on the molding section, which is the 3rd section. Then the last one, we have the compressor, air compressor. So what the air compressor does, the air compressor takes the air from the atmosphere, compress it into a cylinder, then which in turn is now being fed to the machine. So the compressor itself also have a safety measure. As it's taking the air from the atmosphere, take it to the cylinder, it has a pressure switch that cut off the machine, so that the machine will stop taking air into the cylinder, so that the cylinder will not explode. It also has a discharge valve, which is on the head of the compressor. It helps to discharge the air so that the compressor can freely restart, because the compressor is on automatic mode. Now, having said that, this control panel only controls the molding section. In that molding section, we have the mold itself, we have the stretcher, then and the blowing section. So that's mold section. The operator takes the preform from the heater, it takes it to the mold. Then the stretcher is now the mold closes. Then the stretcher is being injected into the preform. The stretcher has a piston inside that is being injected into the preform. Then, which in turn, the blowing will not take place. A high pressure air is now being injected into the preform, then and expand the preform into the mold, just as I initially explained before. So now I want to on this control panel, how it controls the mold, the stretcher, and the blowing section. So now I have to put off the control panel and on it again. Now let me put it off. We got a power adapter. What the power adapter does is to convert 240 volts to DC to 12 volts, DC volts. So I decided to use 12 volts because for safety reasons. So in the market, you can get 240 volts, you can get 28 volts, you can get 110 volts, depending on the manufacturer. So it doesn't really matter. So in this project, precisely, I'm using 12 volts adapter, converting 240 volts to 12 volts. Here with me, I also have a breaker for the protection of this control panel. Got a breaker. Then here with me here, I got indicator light. This indicator light represents the mechanical aspect of the machine, because ordinarily I cannot bring in the machine here. So I got these ones to represent the mechanical aspect, the mold, the stretcher, and the blowing. Just as ordinarily, if the machine is here, how it will function. So that is what this one is doing here. So here with me again, I got the light. This light here, this white light, it stands for, it comes on when it is in the manual mode. This one, you see M on it, it represents the mode. S represents the stretcher. B represents the blowing, which the light is also there. We got the amber color, we got the blue, we got the green represents the blue, the green represents blowing, the S represents the blue light, which is the stretcher, the mode represents the amber. Then here with me, I got two-way selector switch, which represents each of the parts, the mode, the stretcher, and the blowing. So if it's on manual mode, I want to operate this section individually. I use this two-way selector switch to operate, to control them. Then on my right, on this other side, I got three-way switch, which is used for automatic, either automatic mode or manual mode. On my left hand side here, we got A, which stands for automatic. Then the middle stands for, which is 0, stands for off state. It's neither on automatic or on manual. And while the right hand side, M, stands for manual selection. Then this one, you can see the name written on it, emergency stopped. So once the operator is operating the machine and he discovers that there's an emergency, he just have to press down, then the machine stops on its own automatically. Then this one here is a push button. What it does, the operator just have to push it, then the machine starts working on its own. It has its own cycle, how it works. It just it starts working, then it gets to a time it stops. The bottle is being formed. It takes out the bottles and keep it and put another preform, takes another heated preform and put it on the machine and press again. That is how it continues. So now I want to on the machine. I want to put it on automatic mode and see how it works. Let's see. Now it's on automatic mode. The operator, I'm representing the operator now. So let me start the machine. You see the light comes up, you see the stretcher comes up, you see the blowing comes up, and you can also see from the indicator light the actual machine itself, the molding machine itself, the components. These are the light that represents it. So now the machine has gone off. It simply means that it has completed cycle. The bottle is being formed already. So the operator takes out the bottle and it puts in another heated preform again. It starts again. The cycle continues. That is how it works. Now, this machine, within 30 seconds, it produces 2 bottles because it is just for 2 cavity. And it's producing 2 bottles at the same time. So 30 seconds produce 2 bottles. Then 1 minute, it produces 4 bottles. Then in 1 hour, the operator can produce 240 bottles, empty bottles. So that is how it works in the automatic mode. So now I want to go to off. This is off session now. If I press, you see it's not working. If I go to the manual, you see no light is coming up, nothing is coming up. It shows that it is in the off state. Now I want to go to manual. This is my right hand side. You see this light, like I said earlier, that it stands for manual state. Is to indicate to the operator that this machine is in a manual state, which we can see now the light just comes up. Now I want to operate it. I want to operate the mode. Let's, for example, the machine has an issue. The operator wants to check what is the issue. Is it the mode? Is it the stretcher? Is it the blowing section that has an issue? It wants to find out. It goes to the manual mode, then it operates each section individually and see, is it the C that has an issue? Is it mechanical fault? Is it electrical fault? Is it the coil? And so on and so forth. So now let's start from the manual. For the mode section, I go to the mode, I check. You see the light, you see this light you see now represents the mode section, which is the, let's say, the coil, the valve that is controlling the mode section. This is the light. It shows that it's working. I check it's working. There's power gets to the place. Then I off it. Then I on it again. It's all working well. Then I off it again. Then I go to the stretcher. Let me check the stretcher. You see the middle one is the stretcher. The stretcher comes down and I see that, yeah, it's working. Everything is working. Then I off it again. I on it again. It's working. Then I go to the blowing section. You see the blowing section. You start hearing the sound. You start hearing the blowing sound. The head sound from the machine. You just be coming out. It tells you that the thing is working. If it's not working, you can also see it. Then you can troubleshoot it and find a solution on how to get it fixed. That is it. You can on the three. The three of them can be on. Simply means that the mode will close. The stretcher will come down. The blowing will you just want to test. Let's try it. Stretcher, mode, stretcher, blowing. You see the three comes up. So it simply means that the mode is low, the stretcher is down, the blowing, you just hearing the blowing. The sound of the pressure will just be making that sound. You just be there. You just want to find out something. You can off them individually, just as you can see. That is how it works. So this project is something I've been doing for years. I've used it to help my clients to sort out their machine challenge whenever there's a major breakdown. So, and this one is even easy to maintain. It's easy to maintain. So before I forget, this machine, it has, this control panel has a timer relays inside. As you can see, these timer relays, they are all, these timer relays here, these are the timer relays. They can be adjusted by the operators. Either the machine is too slow or it's too fast, they just adjust them. We also got, is it 8-pin timer relay. We got another 2 relay, not timer relay this time. This one are 14-pin relays. So which can also be, is part of the control aspect of this machine. So that is that. So that is basically all of this machine. So now the limitation of this machine is that because I'm using relays, So it occupies space in the machines sometimes. So sometimes if there's problem, there's a fault, to troubleshoot it is you have to come up with the diagrams, have to trace the wire because it has so many cables. You understand? So, but I've decided to convert this project to PLC, programmable logic control, and also I incorporate HMI, which is human machine interface, into it, so that if the operator want to carry out any changes on any adjustment, any settings, it just have to use the screen instead of going to the relay and adjust, because that relay is an analog relay. You just have to touch it on the screen, and it doesn't require space. It's just a small module, PLC module. You can just do this, but you just have to use ladder diagram to just explain, just to use ladder diagram to write the program and incorporate it into the PLC module, and it to be more better than using this elaborate components. So that is what I'm also working on now. So as a research, so I've downloaded some programs that I'm learning, so that to be able to learn how to write these programs. So that is it for now. Thank you.